My name is NURHAFIZHAT and I'm from batch 17.
My name is Shakila binti Al-Razak and I'm from batch 17.
My name is Muhammad Al-Ikhwan bin Abu Hassan from batch 17.
My name is Muhammad AZIQ Hafiz bin Muhammad Zain, DEM 031907
Hi, my name is NURUL ATIRAH, DEM 03190555 and I am from batch 17.
DEM 031907.
My name is Isadm, DEM 03190558.
The objectives of this topic. So why we learn about the information system acquisition, development and maintenance. First, it covers controls for the identification, analysis and specification of information security requirements. The second one, it serves as guidelines for people to understand the rationale of the system development lifecycle SDLC. The third one, it gives awareness of the most common application development security faults. Next, this topic also explains cryptographic components. And the last one is that this topic helps an organization in obtaining quality staffs or additional skills, knowledge of a business intelligence. What is information system acquisition, development and maintenance? According to section 14 of ISO 27002, the information acquisition, development and maintenance ISADM focuses on the security requirements of information systems, application and code from conception to destruction. It particularly emphasizes vulnerabilities management to ensure integrity, cryptographic controls and the security of system files.
Initiation phase. The initiation of a system or project begins when a business need or opportunity is identified. A project manager should be appointed to manage the project. This business need is documented in a concept proposal. After the concept proposal is approved, the system concept development phase begins. Development phase. The detailed specifications produced during the design phase and translate into hardware, communication and executable. Implementation phase. The system or system modifications are installed and made operational in a production environment. The phase is initiated after the system has been tested and accepted by the user. Operations and maintenance phase. The system operation is ongoing. The system is monitored for continued performance in accordance with user requirements and needed system. Modifications are incorporated. The operational system is periodically assessed through in-process review to determine how the system can be made more efficient. The disposal phase involves the orderly removal of surplus or hardware, software or data. Primary tasks include the transfer, achieving or destruction of data records. Management should transfer data from production system in a planned and controlled manner that includes appropriate backup and testing procedure.
Commercially available or open software. 1. CLDC principle apply to commercially available software, sometimes referred to as commercial off-the-shelf software code, and to open source software. 2. Commercial software should be evaluated to make sure it meet or exceed the organization security requirement. 3. It is important to be aware of and understand the release stage. 4. Only stable and tested software release should be deployed on production servers to protect data availability and data integrity. 5. Once installed, all software and application should be included in internal vulnerability testing.
First one is software release. Alpha phase is an initial release of software for testing. Alpha software can be unstable and can cause crash or data loss. Beta phase indicates that the software is feature complete and the focus is usability testing. Second one is a software update. Updates should be subject to the organization change and should be tested before being implemented. The third one is the testing environment. The worst case scenario for a testing environment is a company does not have one and is willing to have production server double as testable. The closer to the production environment, the test environment is, the more the test result can be trusted. The last one is protecting test data. Live data should never be used in a test environment because it is highly unlikely that the same level of data protection has been implemented. Exposure of protected data would be a serious violation of ethics, confidentiality, and regulation requirements.
Web Application Security Project, or OWASP, is an international non-profit organization dedicated to web application security. One of the OWASP core principles is that all the material be freely available and easily accessible on their website, making it possible for anyone to improve their whole website application security. Injection is a technical attempt to send data to an application in a way that will change the meaning of command being sent to an interpreter. For example, the most common example in SQL injection where the detector sends 101 or 101 instead of just 101. When include the SQL query, that this data change the meaning to return all records instead of just one.
The importance of season management. We have 5 important things. First, if season management assets such as user, credential, and season IDs are not properly protected, the season can be hijacked and taken over by the malicious intruder. Second, when credential can be guessed or overwriting with account management function. For example, account creation. Second, change password. Third, recover password, and with season ID. The identity of the authorized user can be impersonated. The third one is season ID exposed in the URL do not time out or are not invalidate after successful log of malicious intruder have the opportunity to continue and auto-retect season. The fourth one, a critical season design equipment must be strong, authentication and season management control. And then lastly is common control for protecting authentication, credential and season ID is encryption. The next one is policy, application development policy. System owner are responsible for oversight of secure code development, implementation, operation and disposal requirement. Security requirement must be defined and documented during the application development and implementation phase. Code development will be done in accordance with industry best practice.
Cryptography, the art and science of writing secret information. The origin of the term is from the Greek word cryptos, meaning hidden, and graphia, meaning writing. There are 3 goals in cryptography, which are confidentiality, integrity, and authenticity. For the first one, confidentiality, unauthorized parties cannot access the data. Data can be encrypted, which provides confidentiality. Then, for integrity, assurance is provided that the data was not modified. Data can be hashed, which provides integrity. For the third one, authenticity or non-repudiation, the source of the data is validated. Data can be digitally signed, which ensures authentication and integrity. Next, moving on to the elements in cryptography, which are encrypt, decrypt, ciphertext, and the key. For the first one, encrypt, it is the conversion of plain text into what is known as ciphertext using an algorithm called a cipher. Then, a ciphertext is a text that is unreadable by human and by computer. The third one is decryption. It is the inverse of encryption, which is the process of turning back ciphertext into readable plain text. And the last one is the key. The key is a value that specifies what part of the algorithm to apply, in what order, and what variables to input. Similar to authentication passwords, it is critical to use a strong key that cannot be discovered and to protect the key from unauthorized access. Protecting the key is generally called as the key management. The next element in cryptography is hashing, which is the process of creating a numeric value that represents the original text. Unlike encryption, hashing is a one-way process, meaning that the hash value never written back into plain text. Moreover, we also have digital signature. A digital signature is a hash value that has been encrypted with the sender's private key. The hash must be decrypted with the corresponding key. This proves the identity of the sender, and hence it provides authenticity and message integrity. Moreover, we also have Caesar alphabets. As you can see, the Caesar alphabets is different from the standard alphabets because it ends with W, and the other alphabets, the rest of the alphabets after W is put in front before alphabets A. So it's like X, Y, Z, A, B, C, D, and so on. And the last one is W. It is shifted like that so that people can use it to send a message that contains secret information.
First is Public Key Infrastructure. PKI is the framework and service used to create, distribute, manage, and revoke public keys. Second is PKI is made up of multiple components including a certification authority, a registration authority, client notes, and the digital certificate. Third is the certification authority issues and maintains digital certificate. Fourth, the registration authority performs the administrative function verifying the identity of user and organization, requests a digital certificate, renewing certificate, and revoking certificate. The digital certificate is used to associate a public key with identity. Certificates include the certificate holder's public key, serial number of the certificate, certificate validity period, unique name of the certificate, issue, digital signature of the issued, algorithm identifier. Best practice for key management. So number 1, the key length should be long enough to provide the necessary level of protection. So number 2, key should to be transmitted and stored by secure means. Number 3, key values should be random and the full spectrum of the key space should be used. Number 4, the key's lifetime should correspond with the sensitivity of the data it is protecting. After that, keys should be backed up in case of emergency. Lastly, keys should be properly destroyed when their lifetime ends, and keys should never be presented in clear text. Key management policy. So point number 1 is the Office of Information Security is responsible for key management, including algorithm, decision, key security and resiliency, maintaining digital certificates, and user education. The office will be published cryptographic standard. Point number 2 is it is responsible for implementation and operational management of cryptographic technologies. Point number 3, encryption is required whenever protected of confidential information is transmitted externally. The encryption mechanism must be NIST approved.